So we've been dealing with quadratic equations. We've been dealing with things that have a squared term in them. We've developed our skills in factoring. We've used the quadratic equations to solve them. Now we're going to see what these actually look like when they're put on the XY coordinate plane. And so basically, if you have a squared term in your equation, you're going to make a parabola. A parabola is a function. It passes the vertical line test. It goes on forever. It is a series of x's and y's on the coordinate plane that make these equations true. So we're going to start out with two different equations here. And so I'm just going to actually change the color. We've got this x squared. Oops, that's not the right color either. Here, this one. This is this one. And the other one, the green one here, is this one. And so in these ones, what we can talk about is the different components or the different identifying features of these parabola, of these quadratic equations. So we're going to start off with the vertex. The vertex is like the apex. It's the highest or the lowest point of our parabola. It's going to open upwards when we have a positive a squared or a value. So here you could see that there's a positive a value. It makes it happy, if you will. Do you see the shape of the smiley face there? That's why I put these eyes on it. I don't know if that helps. Or if it's a negative a value here, like in the green one, we end up with a downward shaping parabola. And again, the vertex is right at the tip of these smiles on the face, right? So there's the vertex and there's the vertex. So all we're doing with that is saying that this is a minimum or a maximum. All right, the other components that we're going to take a look at are summarized below. So just looking at one of these, so we picked the positive one here, right? As an example, it should actually equal 0. The domain is all values of x. And so we talked about that before. These graphs, it doesn't say it on here because they were made with a program that didn't include it. They go on forever. And so all the values of x are going to be possible values. And so we might say all values of x. You might say from negative infinity to positive infinity, right? The range on this thing, the range is just going to be on the y-axis, right? And so the y-axis, we're stuck at -1 to positive infinity. Or you could put it as an inequality statement and write it like that. Either way, it's the same concept that we're talking about. The intercepts, if I circle back to that one, are where the graph touches the x-axis. You could technically do the y-axis, but it's not normally calculated. Honestly, you can probably ignore that one entirely. So the x-intercepts here, x would equal -1 or x would equal a -3. That's the kind of solutions that we were finding. I might have mentioned that in an earlier section, right? That's where the graph is going to touch the x-axis. And so these could be found by factoring or the quadratic equation. The other component, the other feature of a parabola or a graph of a quadratic equation would be the axis of symmetry. So you will notice that it's a symmetrical smile, right? And the x value that it's symmetrical around is that point right there. So we could also list the vertex. I should have done this as a coordinate, right? So the vertex for this one, just going through the example. So the vertex for this one specifically would be x is equal to -2 and y is equal to -1. So kind of going through all of those with a little bit of, of an explanation. You might want to add little notes that make sense to you. So these are the important bits, right, that we're talking about. We're really going to focus on the x-intercepts as a minimum. It doesn't really matter the y-intercepts so much, but technically you could do it that way. So let's take a look at these. So this is y equaling f of x, or in function notation, f of x equals x squared. So just as a bit of a review, these are relations, but they are also functions because they pass that vertical line test. So that means that we can write them in function notation. Okay, so the vertex for this one would be right down here. That is an ordered pair of 0, 0. The x-intercepts for this one would be none. It doesn't cross the x axis. Remember, this is the x-axis and this is the y. We could say the y-intercept, but let's not bother with that one. The domain of this, so that's all values of x, right? I did note before that these lines go on forever. So all values of x. The range of it, these are going to be y values that we care about. So 0 to positive infinity. You could say y is greater than or equal to 0 if you wanted to say it that way. And the axis of symmetry is x equaling 0. Let's try another one. So this one's a little more complicated. It is in function notation. You could say y equals, right? Same thing. The vertex for this one would be the ordered pair of 0 and 2. The intercepts, again, it doesn't cross the x-axis, so none. The domain is going to be all values of x, or negative infinity to positive infinity. And the range of it is going to be 2 to infinity, or 2 and greater. The axis of symmetry is going to be that x equals 0. One more to do here. Again, we're just taking a look at what those words all mean and then identifying the features of these graphs. So this quadratic equation in function notation, we can see it graphed over here. The vertex is going to be right there. So that is -2 and 9. The intercepts actually exist on this one finally. So x equals 1 or x equals -5. The domain of this, these go on forever. So all values of x. The range of it is going to be -9 to infinity, or y is greater than or equal to -9. And the axis of symmetry is x equals a -2. So this key bit of the vertex is what we're going to kind of hone in on next. So this vertex is really important because it's quite an anchor for these parabolas. You'll notice that they're symmetrical around the vertex. You'll also know that if you know the vertex, you also know the axis of symmetry. So this vertex is going to be worthwhile for us to take a little bit of time and learn a little bit more about. So you can find the vertex of a quadratic equation by using a bit of a formula. So the x value of any vertex is going to be -b over 2a. So we're used to seeing now, the standard form. We've used the a, b, and c as we use the quadratic equation, but now we're going to use the vertex formula to start with an equation and figure out where does it have its vertex. So as we go through with this specific example, switch back to a color alike. So my A value is 2, my B is a -4, and my C is a 9. My equation, my vertex equation is that. You'll notice that this is on your formula sheet as well. If I sub into it, x is equal to negative of -4, always subbing in with brackets, and 2 times 2. So x would actually equal 4 over 4, or x equals 1. The vertex is going to be an ordered pair. I already know that x is equal to 1, but now I have to figure out what y is equal to. You'll remember when we did function notation, I said f of x is y. So I could say that y equals all of this. To confuse things further, I could also use that function notation and sub a 1 in for x and then solve for my y value. You may have already forgotten function notation because it seems like a funny thing to remember. So evaluating this function at 1, I get, what is that, 7? So that can complete my ordered pair. That is the vertex. That's the point of the parabola. It's either going to be a minimum or a maximum. You'll notice there's a positive sign here. That means it's going to be happy face. So it's going to be minimum. Let's do some of these. So we've got this idea that we have the parabola, right? We have our vertex formula. I have A values being 3, B values being -6. And I know we don't need a C value in this, but I'm going to write it anyway, right? In the vertex formula, X is going to equal -B over 2A. X is going to equal 6 over 6, or another one, 1. So now I go back to my original function and say, well, what is y going to be? It's going to be the value of the function when x equals 1. So 3 times 1 squared. That'd be 3 minus 6 plus 5. I get f at 1 is equal to 2. And again with these, I should be getting used to, hopefully, seeing this as an ordered pair. Right? I figured out my x value with the vertex formula, and then I sub that value back into my original equation to find my y value. Last one, might want to pause the video and try this one on your own. The vertex formula is going to give me the x value, so -b over 2a. X is going to equal a -1. So that's the value that I sub into my original equation to figure out the y value of my vertex. Watch your signs in this one. Easy to go wrong in them. F at -1 is actually equal to -5. And so again, writing this as an ordered pair, because that's where you would find the vertex of this parabola. One more to try with this. So I've got an A, a B, and I know I don't need the C value for my vertex formula. This x is not an intercept. We're using the vertex formula as opposed to the quadratic equation. So it gives me the x value of my vertex. So -b all over 2a. And again, that's something you don't have to have memorized. It's in your formula pages. So I get an 8 over 4. I get that x equals 2. And then I figure out the other part, right? I'm trying to fill in an ordered pair that is my vertex. So I go back with that 2 and plug it into my original function to calculate the y value of my vertex. So 2 times 2 squared minus 8 times 2 minus 4. What is that? 2 times 4, 16 minus 4. 8 minus 16 minus 4. Oh my goodness. Handy calculator. Hopefully I got it all in there. I get negative 12. And that completes my ordered pair. That is the vertex of this parabola. The last one, I've already kind of gone a little bit ahead of myself here. Is the vertex a maximum or a minimum? What we're going to look back to, is it a positive a in the original function or is it a negative a? So this is the sad face, right? This is a negative a value. And by a, I mean the coefficient on the x squared. This is a positive a value. So this would be a minimum, this would be a maximum. And it's really turning the smile and talking about that vertex that is an ordered pair as we were just seeing it. So you can go back and take a look at all the other pictures and identify as a minimum or a maximum. And we'll continue on with trying to go to putting these things on the graph.